The global AI boom is pushing technology to its limits. And the latest chapter in this story comes from two industry giants, Samsung and Nvidia. Reports suggest that Samsung is in advanced negotiations to supply HBM4 memory chips to Nvidia, the world's most dominant AI GPU maker. This partnership could reshape the semiconductor landscape and redefine how future AI systems are built. But what's driving this sudden collaboration? What makes HBM4 so important? And how will it impact the next generation of AI hardware? In this video, we'll explore everything, from what HBM4 is and why it matters, to how this potential Samsung-Nvidia deal could challenge SK Hynix, Micron, and others in the high-speed memory race that powers artificial intelligence. Before diving into HBM4, it's important to understand what makes high-bandwidth memory so revolutionary. Traditional memory systems like GDDR are fast, but they face physical and thermal limits. HBM changes that by stacking DRAM chips vertically, connected through ultra-fast microbumps and through silicon vias. This design drastically increases data throughput while keeping energy consumption low, perfect for AI workloads that need massive parallel data processing. Each new generation, from HBM2 to HBM3 and now HBM4, doubles the performance and efficiency of the previous one. HBM4, currently in late development stages, is expected to deliver over 1.6 terabytes per second of bandwidth. That's nearly twice the speed of HBM3E, opening doors for more advanced GPUs, AI training clusters, and even quantum-scale data simulations. Samsung has long been known for its dominance in DRAM and NAND flash production. But in the high-end AI memory market, it has been lagging behind its South Korean rival, SK Hynix. Determined to change that, Samsung has accelerated development of its HBM4 technology, which uses 5th-generation DRAM stacking and new interposer materials for higher heat tolerance and reliability. Partnering with Nvidia would be a massive win for Samsung, allowing it to secure a seat at the AI table dominated by Hynix. Beyond hardware, Samsung aims to strengthen its position as a key AI infrastructure provider, combining its semiconductor manufacturing expertise with its growing AI R&D. If the talks with Nvidia turn into a long-term supply deal, Samsung could gain billions in revenue and influence, reshaping global semiconductor alliances. Nvidia's GPUs are the backbone of today's AI revolution, powering everything from ChatGPT to autonomous vehicles. However, as AI models grow exponentially, with trillions of parameters, Nvidia's chips are increasingly bottlenecked by memory speed and bandwidth. This is where HBM4 becomes crucial. Nvidia's next-generation GPU architecture, codenamed Rubin, will likely rely on HBM4 to sustain the enormous data throughput required for AI inference and training. Currently, Nvidia depends heavily on SK Hynix for its HBM3E chips, but diversifying supply is critical to avoid production delays. Partnering with Samsung would not only boost Nvidia's resilience, but also allow it to test and optimize different HBM4 designs for higher energy efficiency and thermal management. This partnership could define the AI hardware ecosystem for the next decade. HBM4 represents a leap in memory design, both structurally and technologically. It's expected to feature a 2048-bit memory interface, double that of HBM3, and a chip stack height of up to 16 layers. Each layer precisely bonded using advanced hybrid bonding techniques. It will likely employ 2.5D and 3D packaging, where the memory and processor sit closer together for minimal latency. Moreover, HBM4's thermal management is a major focus. It integrates new materials and design methods that allow it to handle over 1.2 volts of operation while maintaining lower heat output. This will make it ideal for AI data centers, where efficiency and cooling are major challenges. In short, HBM4 is not just faster. It's smarter, smaller, and designed specifically for the AI era's most demanding computational workloads. If Samsung secures the HBM4 deal with Nvidia, it could shake up the entire semiconductor hierarchy. SK Hynix, currently the market leader in HBM, supplies over 70% of Nvidia's AI GPUs, while Micron is still finalizing its HBM4 roadmap. Samsung's entry into the high-performance memory race could trigger a new wave of innovation and pricing competition. This also ties into the broader geopolitical landscape, as nations like the US and South Korea push to secure semiconductor supply chains amidst growing tensions with China. A successful partnership could not only boost Samsung's profits, but also enhance South Korea's strategic influence in global chip manufacturing. Meanwhile, Nvidia would gain a more balanced supply chain, reducing risk and ensuring it stays at the forefront of the AI arms race. As the world races toward more powerful AI systems, hardware innovation becomes the foundation of progress. The potential partnership between Samsung and Nvidia represents more than just a business deal. It's a glimpse into the future of computing. HBM4 could enable faster AI training, smarter models, and greener data centers, all while pushing memory technology to unprecedented heights. Whether this collaboration becomes reality or not, it highlights one undeniable truth. The next revolution in artificial intelligence will be powered not only by algorithms, but by the memory chips that feed them. Samsung and Nvidia's talks might just mark the beginning of that future. A future where memory speed defines the pace of human innovation.